So we are going to talk about the natural language processing, or what we call the NLP, using PyTorch. So um, we've worked with images using Torch Vision in the previous um, videos, and images are already numbers in pixels. It's easy for computers, right? Images are already numbers because of its pixels. It's easy for computer to compute it, but now, in text, natural language processing, we are working with text. Text is not a number, so computers cannot understand it directly. Um, this is the core problem in natural language processing. So, why text is harder than images? Images represent as pixel values like numbers. Example 255, 120 is 0. And text made of symbols like letters, words, punctuations. These have no numeric meaning. So we must convert X into numbers. So first step, we convert words into numbers. Like this is the foundation of natural language processing. Like example is I love AI. It becomes 1, 45, 78. Like the I is being 1, the love is 45, the AI is 78. Each word gets a unique ID. So this process starts with tokenization. Why text is still difficult, even after converting to numbers. Even if text becomes numbers, it's still very different from other data. So the key problems is text is variable, same meaning but different sentences. Uh, Example, I am happy, I feel great, this is awesome. Same idea but different words. And text is sequential. The order matters. So example, dog bites man, man bites dog. Same words, but different meaning. Next is context matters, very important. Uh, like example, bat flew in cave. We are referring to animals, but the baseball bat we are referring to sports. This is called polysemy, one word but multiple meanings. So next is words depend on each other. Meaning comes from relationships between words. It's not just individual words, but this is why the old model fails because um, this is why modern models like transformers succeed. Next is variable length problem. Text can be one word, one sentence, full book, and models need tricks like padding, like adding extra tokens, and truncation is cutting text. Next is vocabulary problem. The language keeps growing, like having slang, new words, hashtags. Models may see unknown words. This is called out of vocabulary or OOV problem. So the solution is subword optimization. Next is ambiguity. This is one of the very hard problems. Like there are three types of this ambiguity. That is lexical ambiguity, word has multiple meanings, like the example in public, like in the bat. Syntactic ambiguity, the sentence structure is unclear. Semantic ambiguity and that, and lastly, the semantic ambiguity is meaning depends on real world knowledge. So humans solve it easily, machines struggle a lot. So, and why natural language processing is powerful because despite difficulties, natural language processing is very useful and for classification tasks, uh, labeled full text like sentiment analysis, form detection, topic classification, chat with intent detection. Next is sequence task. Label each word, like example, Alice works at Google Manila. So the output is Alice means person, Google means organization, Manila means location. This is called inner R or name entity recognition. It also includes post topic like noun, verb, etc. So the narrative task is model creates, like for examples, summarization, chatbots, translation, story writing. These models generate text word by word. Next evolution of NLP. So the old NLP rules is handcrafted features. As a modern NLP is deep learning, models learn patterns automatically. So why PyTorch is used? PyTorch is one of the most popular tools in natural language processing. It helps us to pre-process text, convert text into tensors, numbers, build models, train models. Important to note about what a start text is. Before we PyTorch had start text, but now start text is no longer a main thing. Instead, we use the PyTorch directly, or use tools like Hugging Face. It gives more flexibility. So yeah, that's it. So we need to remember the keywords from um, this conversation is natural language pipeline is text organization, convert numbers, feed into model learns patterns.